Welcome to Statistics for Sustainable Development. This is the first of a series of videos where we show how statistics can help us to make sense of some of the world's most pressing issues. In this first video, we look at the median, the standard deviation, and the normal distribution. One of the biggest issues in today's world is hunger. According to the UN in 2023, nearly 1 in 11 people worldwide faced hunger, while more than 2 billion experienced moderate to severe food insecurity, almost a quarter of the world's population, and it's children who suffer the most. In 2024, 150 million children were stunted, defined as being too short for their age. This results from chronic or recurrent undernutrition, usually associated with poor socioeconomic conditions, poor maternal health and nutrition, frequent illness or inappropriate infant and young child feeding and care in early life. Stunting holds children back from reaching their physical and cognitive potential, and nearly half of deaths among children under 5 years of age are linked to undernutrition. So how can statistics help us to understand and address issues of child malnutrition? Let's start by looking at the UN's Sustainable Development Goals, the SDGs. There are 17 SDGs in total, agreed by UN member states back in 2015 with the aim of delivering the 2030 Agenda for Sustainable Development, a blueprint for peace and prosperity for people and the planet now and into the future. We focus on one SDG in particular, SDG 2, Zero Hunger. Within this SDG, there is a target to end all forms of malnutrition by 2030. Progress against this target is monitored using a number of indicators, one of which is the prevalence of stunting among children under 5. This is defined as having a height for age of less than -2 standard deviations from the median of the World Health Organization Child Growth Standards. Okay, so I think this indicator needs some serious unpacking. First question, what is height for age? I did a bit of digging on this and found that the WHO Child Growth Standards are derived from a study conducted around the turn of the millennium, with over 8,000 healthy breastfed infants and young children from widely diverse ethnic backgrounds and cultural settings. These children had their lengths or heights measured at different ages to build up a profile of what a healthy growth rate should look like. Their data were used to construct growth standard charts like this one. This is the one for girls, and this is the one for boys. Second question, what is the median? So imagine we took all the healthy girls of a particular age in the world and lined them up in order of height. The girl right in the middle of that line has the median height for that age. The green line on the growth chart shows the growth trajectory of the median healthy girl. We can see that the median girl is 49 centimeters long at birth, then 74 centimeters on her first birthday, and 86 centimeters on her second birthday. By her third birthday, she's being measured in height rather than length, and found to be 95 centimeters tall, growing to 103 centimeters at age 4 and 109 centimeters at age 5. Third question, what is the standard deviation, and what does it mean to be less than -2 standard deviations from the median? Of course, not every healthy girl will follow the exact same trajectory as this median girl. For lots of reasons, including genetic factors, some girls are bigger and some are smaller. So instead of there being a single healthy height for each age, we can say that there is a distribution of height for age that is deemed healthy. The standard deviation tells us how spread out the distribution of healthy heights is at each age. For girls, the standard deviation is about 1.5 centimeters at birth and rises to about 5 centimeters at age 5. On the growth chart, the red lines track the lengths and heights 2 standard deviations above and below the median respectively. And the black lines track the lengths and heights that are 3 standard deviations above and below the median respectively. We can see that these lines fan out as children get older, showing that there is a wider variation in healthy heights among 5-year-olds than among newborns. Some clever statisticians did some clever analysis of the data and found that height for age among healthy children under 5 is normally distributed. This is a special distribution that has 2 important properties. Firstly, it is symmetric. This means that healthy children are equally likely to be a centimeter below the median height for age as they are to be a centimeter above the median. Secondly, The further away we get from the median in either direction, the less likely we are to find healthy children. We can show this on another diagram. This is the normal distribution. The horizontal axis denotes how far away we are from the median, measured in standard deviations, or z-scores. The middle point, where z equals 0, is the median. By definition, this point is 0 standard deviations away from the median. All of our healthy children can be found somewhere underneath this bell curve. The height of the curve denotes how many children are found in each part of the distribution. The highest point of the curve is at the median, where we find a lot of children. Then the further away from the median we get in either direction, the fewer children we find, dropping almost to 0 when we get to height for age of 3 standard deviations above or below the median. The normal distribution tells us that 68% of our healthy children are in this shaded area, within 1 standard deviation either side of the median, with a z-score of between -1 and 1. 95% of our healthy children have a z-score in the range -2 to 2. In other words, there is a 95% probability that a healthy child has a height for age of within 2 standard deviations of the median. This leaves a 2.5% probability that a healthy child is more than 2 standard deviations above the median, and a 2.5% probability that a healthy child is more than 2 standard deviations below the median. Let's go back to our growth chart. Recall that the red lines show this 95% probability interval, where the z-score is between -2 and 2. So 95% of our healthy girls have a height for age within this interval. Any child falling below this line is considered to be stunted, according to the UN definition. Of course, as height for age among healthy children is normally distributed, a small proportion, specifically 2.5% of children who are not malnourished, but are just genetically small for their age, will fall into this bracket. However, if we find a community where a lot of children have a height for age below the red line, then this could be an indication that malnutrition is an issue. We'll show how to test for this in the next couple of videos. But for today, we have seen how an understanding of how the normal distribution works is crucial for making sense of this important SDG target. Like many things we might want to measure, height for age of healthy children is normally distributed. We saw how the z-score tells us how many standard deviations a child is away from the median height for age. The standard deviation is a measure of the dispersion or spread of healthy heights, and we saw how this tends to increase with age. And crucially, we can say that 95% of healthy children have a height for age of within 2 standard deviations either side of the median. Thank you for watching. If you have any questions or reflections on this video, please put them in the comments, and please subscribe to the channel.